Now we are going to see about last type voltage shunt feedback amplifier. We also have current series. Maybe after finishing this, if we have time, we'll see what is voltage and what is the current series feedback amplifier. And this voltage shunt, we have only one example. It is collector to base biasing. Collector to base feedback bias is going to be the voltage shunt configuration. And this R dash connected between base and collector is going to act like the feedback resistor. So, and you see the collector side, the current is splitting. When current is splitting, it is going to be parallel. Input side also, you see current is splitting. So input side also, it is going to be parallel. So if you decompose this R dash, it will be coming parallel as a shunt component in the input side, as a shunt component in the output side, because at both the ends where R dash is connected, there current division happens. When current division is going to happen, it is going to be parallelly connected in the circuit. And voltage refers to output side, and shunt input side. In shunt, what is same? Current is same. So input by input, output is voltage, input is current V by I. So this is going to be a trans resistance amplifier. So you have to find RM and RMF for this amplifier. You have to find RM and